So welcome to the video lecture series on finite languages and automata theory. In today's video lecture, we will be discussing about designing a Turing machine for tackling the problem of an to the power of n, b to the power of n. So when you comprehend the pattern of the problem, you can easily understand, you can grasp the knowledge that the number of a's should be always equal to number of b's. For example, I can take up a sample, give a sample inputs A, B, where you have one A and one B. So this is perfectly valid. When I give dou A's and two B's, so this is also valid. But when I give inputs like triple A and two B's, this is invalid. So what we have to do is, we have to create a Turing machine which accepts equal number of A's and equal number of B's. So first, when you are designing a Turing machine, you have to span from left to right. Whenever you encounter a symbol called as A, you just replace A by some other symbol and move to the right direction. So you have to move to the right direction up to you see an equivalent B here. So when you see a first B, you will take this input A, and when you see the travel in the right, replace this travel in the right. When you see the first B, then you have to replace this and you have to move the left. So in this fashion, you have to repeatedly do this. Now, we will frame a logic that whenever you are replacing a symbol by a new symbol, then move from one state to other state. So this is the logic. First, I will take up this symbol double A and double B. So we'll state Q1. Let us understand this is called as an initial state. So Q1 to Q2. So now from Q1 to Q2 I make a move. So I take this input double A double B. Q1 A is replaced by X and move to the right direction. So when I move to the right, the input will be like this: A, B, B, and this is capital B. Capital B denotes blank symbol. So when A is replaced by X and move to the right symbol, now you have A is replaced by X, and right symbol you have A, B, 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 where the head stands in A. Now you are in the state called as Q2. In Q2, what is the input you are getting? You are getting A as an input. So you should not replace it. You should replace A by A itself. You should not replace A by any other new symbol until you encounter B over here. So you are traveling in the right. So since you are in Q2, you replace A by A and move to the right direction. So you should not touch anything. Now when you move to the right direction, you have X, A, B, B, capital B. Capital B denotes the blank space. Now you are in this direction. Now your read head points to B here. Now you are encountering a new symbol. You are in the state called as Q2. So from Q2 to Q3, make a move that replacing B by some other symbol. Say for example, I replace by Y and move to the left direction. So Q1 to Q2 to Q3. I replace by B by Y and move to the left direction. Now when I replace this, X, A, B is replaced by Y and B is here, B. Now head stands in this position. Now you are in the state called as Q3. Since you are in the state called as Q3, you should not replace this A until you reach this X. You have to travel in the X up to, you have to travel in the left up to you see X over here. Whenever you see X, then you can travel in the right. So you are seeing A here and you are in the state called as Q3. You should not replace immediately. You are in the state Q3. You replace A by A and move to the left direction. When I move to the left direction, you are in the state now X, A, Y, B, B, and head pointer here is here. Head pointer is here. Now you are in the state called as Q3. From Q3, you are having X. Since X is there, Whenever x is there, whenever you see x in Q3, you span from left to right. You can travel in the right direction. So when x is there, you take Q3, you come to Q1. Now capital X is replaced by capital X and move to the right direction. And you are in the state called as Q1 now. So when you replace x by x, x, A, capital Y, B, capital B, now you are in the state called as A. So when you trace this A, now you are in the state called as Q1. You already have a transition. A can be replaced by x and move to the right direction. So you are in the state called as Q1. So x replaced by x and move to the right direction. Y, B, B. When I move to the right direction, you are in Y here now. Now you are in the state called as Q2. The input is Y. Whether we have any transitions for Y here? No, transition is not made for Y. So you have to travel until you encounter B over here. So Y is replaced by Y and move to the right direction. So we make a transition like this. So now you are in the state called as X, X, Y, Y, and B is here, B, capital B is here. Now Y is replaced by Y, move to the right direction. When you are moving the right direction, you will be on standing and the state called as B here. And you are in the state called as Q2. So any other state is there for B? Yes. In Q2, B can be replaced by Y and move to the left direction. So when you go to the state called as Q3. So X, X, Y, Y, B and move to the left direction. When I move to the left direction, you are in the state called as Q3. Y is replaced. Any other transition is there for Y in Q3? No. So Y is there. So Y has to be replaced by Y. Move to the left direction. So Y is replaced by Y. Move to the left direction. So you have to travel in the left until you see an X symbol here. When you see X, now you are traveling the left. Now X, X, Y, Y, B. Now when you travel in the left, you have X here. So you are in the state called as Q3. Since Q3, if you have X here, any transition is there? Yes. X is replaced by X and move to the state called as Q1. When you move to the Q1, then you will be moving to the right direction, and right there is called a symbol called as Y. Y, Y, B. Y. Okay. So now when you move to the right direction, you will be standing here. And you are in the state called as Q1. Any other transition is there for Y in Q1? No, it's not. No other transition is there for Y in Q1. So what you can do is, you make a loop. Y replaced by Y, move to the right direction. So this process continues until you see a B over here. Whenever you see a blank space, then come to a termination symbol. So I see a blank space. So I go to a state called as Q4, and when I see B, blank space replaced by blank space and make a halt symbol. So this is called as a Turing machine for building a language, for accepting a language a to the power of n, b to the power of n. And to make it work, you have to perform the simulation. So I will take up a sample input which of the pattern a to the power of n, b to the power of n, and we will try to solve it. So to perform simulation, I will take A, B, B, and initially you are in the state called as Q1, A, B, B, and B is called as capital symbol. So whenever you are in the state called as Q1, input is A. What you have to do? A is replaced by X and move to the right direction. And you are in the state going to the state called as Q2. So you go to Q2 and A is replaced by X. So it comes X, Q2, A, B, B, capital P. And input state is Q2, input is A now. So Q2 input is A is replaced by A, go to the right direction. So X, A, Q2, B, B, B. Now input is B,